For these three examples, we're going to be converting each rational expression to factored form and simplify it, and then we're going to be identifying the vertical asymptotes and any holes. So if I look at my first equation, I notice that the numerator and denominator cannot be factored any further, so it stays x minus 3 over x plus 6. And in terms of simplifying this, there's no factor in the numerator that matches the factor in the denominator, so it is completely simplified. So in order to find the vertical asymptotes, we are setting the denominator equal to 0 because you cannot divide by 0. So if I set this equal to 0, I would have x plus 6 equals 0, subtract 6 from both sides. So my vertical asymptote here would be negative 6. In terms of the holes, in order to find the holes, we are looking at the factored form and seeing if any factors match in the numerator and denominator that we canceled out. And because there were no cancellations here, there's going to be no holes. Taking a look at the second rational expression, I noticed that the numerator and denominator can be factored. The numerator can be factored by finding the greatest common factor. 2 divides both terms, and what's left is x minus 2. And the denominator is the difference of squares. So I open up double parentheses, alternate the signs, one's a plus, one's a minus. X squared splits as x and x, and then 4 splits as 2 and 2. So I noticed that there is a pair in the numerator and denominator that I can cancel out because this divides as just 1. So my simplified answer here is 2 over x plus 2. So my vertical asymptotes are found by setting the denominator equal to 0 because again you cannot divide by 0. So if I set x plus 2 equal to 0 and subtract 2 from both sides, my vertical asymptote is x equals negative 2. To find the holes, I look at the factor pair that I canceled out here. So I canceled out the x minus 2. So what I do is I set that equal to 0. So if I add 2 to both sides, I get x is equal to 2. So my hole is going to be written as an ordered pair. So it's at 2 comma something. In order to find the y-coordinate, I have to look at the simplified form here and I have to plug in 2 for x. So if I plug in 2 for x, I would have 2 over 2 plus 2, which is 2 over 4, which simplifies as 1/2. So this is where my hole would be, 2 comma 1/2. For the final rational expression, I notice that I can factor the numerator and the denominator. The numerator can be factored by difference of squares, so open up double parentheses, alternate the signs, one's a plus, one's a minus. X squared splits as x times x, and 25 splits as 5 and 5. The denominator can be factored by trinomials, so you're saying what multiplies to 15 and adds to 8, and that would be 5 and 3. So I would have x plus 5 and x plus 3. Taking a look at my rational expression now, I notice that there is a pair that I can cancel out. This simplifies as just 1, the x plus 5 over x plus 5. So my simplified form is x minus 5 over x plus 3. In order to find the vertical asymptote, I set this denominator equal to 0 and solve. So if I set x plus 3 equal to 0, and subtract 3 from both sides, I get x is equal to negative 3. In order to find the hole, I take a look at the factor that was canceled out and I set that equal to 0. So if I subtract 5 from both sides, I get x is equal to negative 5. And you're going to write your hole as an ordered pair. So my x-coordinate is negative 5. How do I find the y-coordinate? I need to look at the simplified form and plug in negative 5 for x. There's 2 spots to plug it in, numerator and denominator. So in the numerator, I would have negative 5 minus 5, and the denominator, I would have negative 5 plus 3. So negative 5 minus 5 more is negative 10, and negative 5 plus 3 is negative 2. And if I divide that, I get 5. So my hole is at negative 5 comma 5.